As David said, my name is Jillian, and today I will be presenting Firewise. So oil wellhead blowouts are becoming an increasing concern in Arctic environments due to harsh weather, cold climates, and remote locations, which all increase the logistical challenges of traditional oil response and recovery. Our project aims to assess whether intentional wellhead ignition is a feasible alternative to traditional oil spill response. Intentional wellhead ignition is when a wellhead blowout is intentionally lit on fire to off-gas the oil rather than allowing it to leak into the environment. To assess whether intentional wellhead ignition is a safe and low-risk alternative to traditional recovery methods, we must develop a modeling framework to assess the risks and environmental impacts associated. Previous work on this project includes developing an oil droplet dispersion model and a combustion efficiency model to study how oil will move once it enters the environment. This year's focus of the project is to assess the mitigation strategies and environmental impacts of intentional wellhead ignition. To begin this process, two tools were made available to us through the National Oceanic and Atmospheric Administration. The first tool is WebNOM, the web-based general NOAA oil modeling environment, which can simulate oil fate and transport and also simulate recovery methods. However, it is not capable of simulating sea ice conditions at this time. The second tool is ARCTIC-IRMA, the Environmental Response Management Application, which is an online web-based mapping tool that contains many valuable resources, including daily sea ice conditions from the National Ice Center and environmentally sensitive areas from the NOAA Environmental Sensitivity Index. By combining these two tools, we can gain a broader understanding of the environmental impacts of an oil spill or wellhead blowout. To demonstrate this process, we have a sample spill located at Endicott Island in the Prudhoe Bay region of Alaska. This spill is fictitious, but historically there was a spill in Prudhoe Bay in 2006, so it does have historic context. Our sample spill consists of 100,000 barrels of crude oil spilled over a period of 12 hours, and the model runs for a period of 3 days. We simulated this without recovery methods and with the recovery method of in situ burning because WebNOM is currently not capable of simulating intentional wellhead ignition. As you can see from the oil budget graph on the bottom of the poster, the red lines indicates the burned oil as opposed to oil floating or beached. We can then take this oil spill and upload it into ARCTIC-IRMA to see how it may overlap with sensitive areas. In the map on the right-hand side of the poster, you can see the same spill modeled in WebNOM and IRMA. For this particular example, this spill overlaps with sensitive bird habitats, as well as vulnerable socioeconomic regions such as oil pipelines and existing road networks. By combining WebNOM and IRMA, we can develop a qualitative assessment for the environmental impacts of an oil spill. This is a key stepping stone in our modeling framework, as our next step is to develop a quantitative assessment that can help stakeholders with real-time decision-making in the event of a real oil spill. Our next step of this project will be to incorporate sea ice conditions to see how this impacts the movement and transport of oil.